Well, welcome to possibly your last video that you will see of me. I know you're excited. I'm excited for you. Hopefully, those of you that are watching these have watched some of my videos along with, the videos that were created by other people. I hope you found them helpful. What I want to do to kind of help you for the final is to go over just a couple of important things for you to help prepare for it. And then I have a few examples that I'm going to work that's from the review. So first thing, the review is the practice test is located in the test section. It is the same setup as a test. You can do it as many times as you'd like. It's a good way to practice maybe budgeting your time, making sure that you have everything you need on your cheat sheet. So you get one page front and back. So use it wisely. I mean, it can be whatever you want. I've outlined that on my materials I allow for this test. So it can be whatever you want. And if anybody gives you any grief, my phone number they should have my phone number, and you have them text me immediately, because the only place I've ever had issues with was at Jefferson. So I made sure I really clarified that front and back of whatever you want. I used to say notes, and then some stickler decided notes weren't examples. Well, in math, what are notes? They're examples. So anyway, sorry. I got off track. I digress. Just, put on there what you need, because I want to see everybody pass this test. What happens is there are some people that either get high levels of anxiety or they're getting help from someone at home, and they don't prepare for the test. They haven't done their own work. They make A's all through the class. Then on the final, they make a 20. Okay? That's not anxiety to me. Okay, that's someone doing your work. Now, you may make a couple grades lower than your average, but as long as you prepare and really study, you get a week almost. You have, the test was due the other day, so hopefully you've been working on this already, but you get a week, roughly. Plenty of time to practice. So those of y'all are going to wait till Wednesday morning, practice and take the test Wednesday afternoon. Bad idea. Don't do that. Prepare like you would be actually taking the test, which means you need to make up your cheat sheet and use only it, a calculator, and your pencil and paper, and take the practice test, go through it. Whatever you get stuck on or don't know how to do, you go back, review it, either look at a video or something else, and then practice it again. But don't get all your notes out, because you won't have all those notes out. You get one page front and back, which should be plenty. It's up to you. I want to see you do well. I will do my best to make sure, you do well, but it's on you. So you must do what's required to get ready for this test, because I will generally have, out of 30 students, I'm going to have 5 or 6 that are going to fail the final. So it doesn't matter what your average is going in. You have to pass the final, which means you must get a 60% or higher. Now, that's what it'll be after I review it. So sometimes, mistakes are maybe a sign here, and, I can give you some partial credit for things like that. It could be rounding errors, which obviously you get some credit for that. But if you just start typing in random numbers for problems, I'm not going to give you partial credit for that. I know I can tell the random number syndrome. Okay, 1, 2, 35, 20. I mean, don't do that. You try to work it. So, it's all coming down to you. So anyway, enough of my preaching. What I'm going to do is I've picked out about, 8, 9, 10 problems. I'm going to try to work through them fairly quickly, because I don't want this video to take all day. But I'm just going to point out some things that I know give students trouble, and hopefully I can help you out with those. All right, so I'm going to move my camera around here, get me some paper. Uh-oh, got to get my glasses. Hold on. All right, yep. It's tough getting old, man. Can't see, get sore. All right, so anyway, let me flip this camera over. If y'all saw my my webcam thing, y'all would die laughing, let me tell you. All right, so let me get this thing set up here. Let me... All right, maybe this will be good enough. All right, so anyway, one of the things that I know we have trouble with, there we go, is the factoring part. So let's look at an example of solving, something that involves factoring. So first of all, you're solving. Now you can use the quadratic formula for anything, but it's much quicker and much more efficient if you can factor. So remember, the key to factoring is, I'm going to set up my two sets of parentheses with my equal sign. The numbers that go here multiply to give you this term. The other two remaining numbers have to multiply together to give me negative 21 with a difference of 3. So that is 7 and 4. Now, I'm subtracting and I end up with a negative 3. So the 7 has to be negative and the 4 has to be positive. Excuse me. That was El Mistako. That should have been a 28 there. Sorry, I'm trying to talk and write at the same time. So anyway, should be factors of 28, negative 28, with a difference of 3. So 7 times 4 is 28, but don't forget it's negative. So I must have a negative and a positive. And I take negative 7 plus 4 gives me my negative 3. I don't even worry about the x's. When I'm setting up my factoring, I'm totally looking at numbers here. The x's will take care of themselves from what you have here and here. Now that's the factoring. Now to solve, and here's where many people mess up, they don't solve. They'll put in their solutions as negative 7 and 4. That's not the solution. The solutions are the opposite signs. Okay, so those are your solutions, because remember, you got to get 0 inside here. So that's got to be a positive 7, or it can be a negative 4. Okay, so that's one type of equation that I see students have trouble with. Another type are equations involving fractions. All right, so fractions means division. So therefore, we have got to get rid of this division by 15, this division by 5, and this division by 10 all at once. So the way we get rid of division is to multiply. But I need to multiply everything by the same number so that they all can divide into it. That means the number has to be at least 15 or larger. So I look for the least common multiple of 15, 5, and 10, and that's 30. So I take 30 over 1 times x minus 9 over 15. I take 30 over 1 times 6 over 5. And I take, and I'm going to put this minus sign here, 30 over 1 times x minus 7 over 10. Now, what I found helpful for some students is to kind of put everything over one fraction. And since these are two numbers, you can certainly multiply the 30 times the 6. I would not distribute here because you're defeating the purpose. Minus 30 over x minus 7 divided by 10. So where I found this has helped my students is it makes it easier for them to divide. Because, see, 30 divided by 15 is 2. And that leaves me with 2 times x minus 9. 180 divided by 5 is 36. 30 divided by 10 is 3, so that leaves me minus 3 times x minus 7, and then you can go from there and solve. I just know the hardest part of these is clearing those fractions, and that's how you do it. Okay, so hopefully that helps. Another problem I've seen are multiplying these complex numbers. All right, these J's tend to mess people up a little bit. So just do your FOIL. So 8 times 2 is 16. 8 times J is 8J. 7J times 2 is plus 14J. And then 7J times J is 7J squared. All right, now, what you have to do here is you combine these two just like they were x's. The difference is J squared is negative 1. So that becomes plus 7 times negative 1, which ends up making it a minus 7. Then 16 minus 7 is 9. Okay? So that's another type of problem that I see students struggle with. Don't multiply unless the parentheses are next to each other. If it's a plus or minus, just add and subtract, which just means you combine like terms. Some people multiply when there's a plus and minus sign in there. That's adding and subtracting. The only time you multiply is when the parentheses are touching. Okay? All right, so that kind of takes care of some of that stuff. Now, I want to move on to some of the triangles. So what I would do, I would, on my cheat sheet, I would make the triangles for RC circuits. I don't care what those nasty drawings look like on the test. If they give you V sub R, V sub C, E, that's the triangle. If they give you X sub C, R, and Z, this is your triangle. So the only thing you need to be concerned about, see, because here's your right angle, is doing trigonometry like you did for any other a trig equation. Now, if you're having trouble with the trigonometry, that's a whole nother ball game. The other issue with this, okay, is in an RC circuit, the V sub C is negative, the X sub C is negative, and the angles are all negative. And I think that messes people up when they do their calculations. But I'm going to show you something here with the RC circuit and how to handle this negative in your calculations. Okay, pretty much you don't need to worry about it. Okay, it's in electricity, electronics, the negative just indicates direction. Okay, so if I just said, for example, that I had E is 53 volts and theta is negative 44 degrees. See, what that tells me is that it's an RC circuit. Even if I didn't know that, it tells me because of the negative angle measure. So I choose my triangle and I put negative 44 here, 53 volts here, and I need to find V sub R and V sub C. So I'm going to find V sub R first, or excuse me, I'm going to go ahead and find V sub C first, so I can illustrate to you how to deal with this negative when you're doing the Pythagorean theorem. All right, so this is my angle. That's my opposite side. That's my hypotenuse, so that tells me I do sine of theta is V sub C over E. Now, the good thing about this is that V sub C is going to be E times the sine of theta. Cross multiply. So V sub C is going to be 53 times the sine of negative 44. Just put in your calculator like that. Or, you know, if you've got the 36, I don't hardly ever use this thing, but I know some of y'all do. Just because I like to see everything as I'm typing in. So for for some of y'all got to do like 44. Hold on, let me get it on again. Okay, you have to go 44 negative sign times 53, which gives me negative 36.816. Now, here's another thing I want to bring up. Some of y'all got to learn how to round. Okay, come on now. You're in college. If I'm rounding to the hundredths place, right there is a 1. Well, to the right of it's a 6. So I add 1 to the 1 to make it 2. If it's less than 5, I leave it as a 1. So make sure you're rounding correctly. And this is negative 36.82 volts. All right. So now I want to find V sub R. Well, V sub R is the square root of E squared minus V sub C squared. Where I think people make mistakes at, they put the negative number in here and they don't group it correctly. You don't need to put a negative number in there because once you square it, it becomes positive anyway. So what I tell my students on campus to do is just put it in there as positive. Okay? And you're subtracting because it's one of the legs. So I'm going to do my 53 squared minus 36.8 squared equals square root. If I can find it on this thing, I hardly ever use this calculator. And I get 38.141, which is 38.14 volts. So it's positive. Okay? So, just be careful with using your signs. And make sure V sub C and E in an RC circuit are negative. Same with R and X sub C. And I did send out video examples on how to calculate X sub C. Look those up. And that's your RC circuit. RL circuits, a little different. Okay, but I would put those on the test as well. I would put those on your cheat sheet as well. Your RL circuits, everything is positive. So in an RL circuit, it looks like this. So for the voltage, you still have E, you still have V sub R, but now we have V sub L. Okay. In the impedance, we have R, we have X sub L, and we have Z. Okay. The only difference in this triangle is your impedance is often measured in K ohms. Well, that K means 1,000. So if you're starting with K ohms, as you calculate, your answer is automatically going to be in K ohms. Going to be in kilo ohms. Okay. So that may be something you need to practice on. All right. Moving right along. Radians to degrees. Now, I know you've been shown pi over 180. Well, let me show you a quick and easy way. And don't forget, I review these tests. So, I'm going to review them and give you the correct answer if you do make your answers decimals. 1 radian is 57.3 degrees. So when I'm converting degrees to radians, I divide. So 180 degrees divided by 57.3 equals 3.14 radians. If I have 4 radians, I multiply by 57.3 and I get 229.2 degrees. Okay, so don't worry about it. Just, that's the best way to do it, in my opinion. And you may miss it, but when I go back to review it, I'll correct it. Okay, so don't worry about that. Polar coordinates to rectangular coordinates. All right, so this is a polar coordinate. So, depending on whether it's Z or E, most of them are Z. Really, what it is, it's this right here. Okay, my angle's positive. That's my hypotenuse. Your rectangular coordinates are just your two legs. Okay, so, basically, this is kind of your X and this is your Y. All right, or your X and your J, whatever. But, if I want to find R, or if I want to find X, whatever you want to call it, well, think of your triangle here. Okay, there's your right angle. This is your hypotenuse. This is your angle. So whatever I want to find here, whatever it is, whether it's R and X sub L, or if it's V sub R and V sub L, whatever it is, use your trigonometry. Okay, so this right here is the adjacent side over the hypotenuse. So I use cosine. So cosine 38.3, whoops, sorry about that, equals X over 13, I can't even write and talk, 0.96. So X is 13.96 cosine 38.3. Okay, so that's about 10.96. Your Y is going to be the sine of 38.3 is Y over 13.96. Again, cross multiply. So it's 13.96 times the sine of 38.3. So that's 8.65. So your rectangular coordinate is 10.96 plus 8.65 J. You got to throw the J in there. Okay? Rectangular is over and up. Just think about everything on a grid. Just think about everything on a grid. All right? Angular velocity. When I see these missed, I'm thinking y'all just missed something. I mean, you just missed something, because angular velocity equals 2 pi times the frequency. So you're just multiplying 2 times pi times whatever number they give you. Don't make it harder than it is. So if frequency is 40 hertz, then my angular velocity is 2 times pi times 40. I mean, it kills me when I see y'all miss this. So I'm thinking, boy, y'all are just missing something. Something's becoming a little too complicated for you. So that is 251, because it's going to usually ask you to round it to the nearest radian, which is a whole number. That's what that means, nearest whole number. And again, if it's less than 5, leave it alone. If it's 5 or bigger, add 1. Okay? All right. So that's angular velocity. Don't miss that. Now, we get into law of sines. Law of sines is difficult, I know, but you can do it. So if I had this triangle here, and this is angle A, angle B, angle C. This is 57 degrees. This is 69 degrees. Side A is 6, and I want to solve the triangle. So when it says solve the triangle, it means to find everything. Well, this angle, I can't use the law of sines right now, because I do not have an angle and a side opposite. But I can find angle A by adding these two angles together and subtracting from 180. So see, that's 126 if I add these two together. 180 minus 126 is 54 degrees. Now I can use law of sines. So I take A over sine A, and it doesn't matter which one I find because I know the other two angles. So I'm going to find side B. Okay? So, and I do this in my class sometimes to help with using these formulas. But if I'm solving for B, well, I know that whatever's on my other angles of my arrows, when I cross multiply, that automatically goes in the numerator, and what's left goes in the denominator. So again, this stuff you should probably write on your cheat sheet. Might help you. That way, I can do 6 times the sine of angle B divided by the sine of angle A. So I take sine of 69 times 6, and I get 5.601. I would carry these out to a few decimal places. Sine of 54 is 0.809. And then divide those two, and get 6.92. Now, whatever it asks you to round to, I'm just going to round to the hundredths place. Okay, so that's what side B is. And then again, you'll have to do law of sines again to find side C. You can't do Pythagorean theorem because there's not a right angle. Okay, the only time you can do Pythagorean theorem is when you have a right triangle. Okay? All right, so that is law of sines. Now, law of cosines. Another one to give us trouble. I'm running through all kinds of paper here. All right, law of cosines. So if I'm given a triangle, the hardest one of the law of cosines is when you're given 3 sides, okay? So if I have side B is 21.26, side A is 26.33, and side C is 19.03, I'm going to use law of cosines. I have to. Now, I always choose, if I'm finding an angle, if I don't know any angles, I choose the angle opposite the longest side, which would end up being the biggest angle. That's always in case you didn't know that, that's what you're supposed to do with these. So I've got to use this nasty formula involving angle A. So that one is A squared is B squared plus C squared minus 2BC cosine of A. Okay. So the hardest part about this one is, the numbers, the way things look. Again, you can substitute your numbers in. Okay. Remember that you are dividing. You cannot subtract this minus 2BC from these. All right. So if I'm going to put these in, there are shortcut ways to do all these calculations. And these take a while. I realize that. Okay, they're not easy. I know that. But you will get some big numbers. 693.27. Okay. 21.26 squared. Plus, I can add these two. 19.03 squared equals 814.13 minus 2 times 21.26 times 19.03 minus 809 cosine A. And you're what I see a lot of people wanting to do is subtract these two. You can't, because this is multiplied by that. So we subtract this over here. So we take the 693.27 minus the 814.13, because we're taking over the other side, and I get negative 120.86 is negative 809.16 cosine A. Now I can divide by negative 809.16. And I get 0.1494 equals cosine of A. So A is cosine inverse of 0.1494. Which is about 81.41 degrees. Okay? So, excuse me, I have a cough. That's what angle A is. And I'm not going to complete this just because, I don't want to be here all day. Now you got to use law of sines, because once I find angle A, now I have angle and side opposite, and then I can find angle B or angle C using law of sines. But try to make sure you get this first one right. That's the toughest. Now, if I was finding side A or side B or side C, just put the numbers in and just, multiply them all together. Okay? Square plus square minus this times this times this, cosine of that, and just type it all in your calculator. Then take the square root. All right? All right, so that's law of cosines. Just a couple other things. Remember when you're solving an exponential equation, and I thought we did pretty good on this on the test, change it to a logarithm. So my exponent equals log base 3 of 0.463. And then I do my change of base formula, where it's the log of 0.463 divided by log 3. So I get negative x is negative 0.7, but don't forget to divide by negative 1. Some of y'all forgot to do that on the test. Oops, sorry about that. So, double check that you're doing this correctly. And then don't forget to... Somebody's calling me on my answering machine at home, so I wanted to make sure it wasn't a telemarketer. All right, lastly, if you're solving a logarithm equation, you change it to an exponential. Don't forget, this is your base. This is your exponent. So 6x minus 4 is 3 to the first power. So 6x minus 4 is 3. Solve from there. Add 4, divide by 6. Okay? So there you go. A little longer than I wanted, but there was a lot that I felt that you probably needed some little refresher on. I hope it helps. I'm going to pull this away now and, again, show you one more last time. Twist this whole thing around. Hope everything helps. But, there's no magic potion for math. Never was. Even when I was your age, never was a magic potion. It just takes work. Okay, so that final is due on or before December 7th, which is Wednesday. I like to get my grades done. My grades have a due date, so final exams are final exams. So just make sure you've set up that proctoring time. Do not email me at 9 o'clock at night when you're sitting in the library needing a password. It doesn't work that way. I'm not going to be like checking my email that late at night. You best give me 24 hours notice, and that's only fair. If you are getting it proctored at somewhere other than one of your campus locations. So, don't, if you're going to panic, it's your fault. Take care of this ahead of time. All right. So good luck. And we'll be talking to you. If I don't, have a happy holiday.